Quick preface before this video starts. I am severely tired. I forgot to sleep the prior night to recording this, so I sound ridiculous. This is Learning Demo 3. How telescopes work. I already covered this. Types of spacecraft missions. I already covered this. Alright. Physical properties of asteroids. Size. It's changeable. There's so many asteroids, they all can't be the same size. Mass depends on the size. The composition, however, is usually rocky, metallic, or icy. And it can change, like in the shape, it can change depending on like conditions, like how it was formed, yada 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 yada. Dynamical properties of asteroids, including their orbits and speed. It varies. It just varies. Origin of asteroids. Leftovers from how our solar system was formed. Like, I get into it later, but our world started in chaos. That's all I'm going to say about that right now. Meteors and meteorites, the differences. Meteors are shooting stars, streak of light, then they burn up. Meteorites are small and very small, don't have a streak of light. Blah, 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 blah. Possibilities of asteroid impacts. Large impacts are extremely rare. However, smaller impacts more often, but there's no need to worry about like them causing like a problem. Like we could usually track them and like see them coming in, and we could usually do something about it. Larger ones, obviously very rare, but it's not zero. Just look what happened to the dinosaurs. Alright, there have been a few spacecraft missions to visit asteroids. However, I'm going to just name like two. Most notably, the first mission was Galileo. It flew past the asteroid. I'm not going to be able to pronounce that. Gaspra? Gaspra. I don't care. Not that I don't care. I'm just tired. DART was the world's first planet defense plan that successfully impacted and moved an asteroid. Like, it moved an asteroid, so now we know that if we find an asteroid coming, we can move it. The physical properties of gas giant planets. There are two in our solar system that are gas giants, and they are usually massive and composed of hydrogen and helium. They don't have a hard surface. Jupiter, the size, radius, I suck at reading numbers, that's just a preface. Okay, radius 43,440.7 miles. The mass, just read read the numbers on the screen. Composition, mostly hydrogen and helium. Orbits are usually like 9.9 hours. Saturn, you can see the stats. Composition, hydrogen and helium, but the core is has dense materials like iron, nickel, surrounded by rocks. And the orbit, it takes 10.7 hours to orbit. Well, ice giants, there's two, Uranus and Neptune, primarily composed of heavier elements like oxygen, nitrogen, carbon, and sulfur. Uranus, you can see the stats. Composition, water, methane, and ammonia above a rocky core. Takes 17 hours to orbit. Neptune, so you can see the stats. Composition, water, methane, ammonia, having a small rocky core as well. Orbits take 16 hours. Describe the structure and origins of planetary ring systems. When impacts occur, like if anything happens where like dust or rock or anything breaks off and goes into the atmosphere and it gets stuck into like an orbit around a thing, boom, rings form. Similarities and differences between major moons of gas giant and gas giant planets. Moons of gas giant and ice giant planets. Similarities, they have bodies and they are actual planets. There's water involved and magnetic fields. Differences, the size and like how it was combined, atmosphere, orbit speeds, like what's happening on the surface. On the surface, whoa. Describe spacecraft missions that have visited Jupiter, Saturn, Uranus, and Uranus. Describe spacecraft missions that have visited Jupiter, Saturn, Uranus, and Neptune from Earth. There was the Voyager 2 that traveled to Uranus and Neptune. Also, the Magic School Bus.
Give you proof. Here's proof of what'll happen to you if you stay here with your
Yo, don't do it! Don't do it! Yo! Yo, holy shit, he dead! Oh, he dead for sure! Miss Riz, you are a bad teacher! How are you gonna afford to go on all these school trips after the lawsuit?
Physical properties of comets. They're frozen gases, rocks, or dust that orbit the sun. Describe dwarf planets. They orbit around the sun, almost round, but their line of where they orbit, there's a lot of debris and they can't get it through. They can't get through. Describe the structure and formation of our sun and planets in our solar system. This is what I was talking to you before. So a supernova occurred, which is just like a star exploded with fiery passion, and gravity pulled in a lot of stuff around, and like pressure occurred, developing energy and hydrogen, helium. Boom, the sun. Literally the Big Bang. Literally the Big Bang Theory. Thank you, Sheldon Lee Cooper. Describe exoplanetary systems and detection of planets around stars, not the sun. Well, people usually find planets and stars if they like see it in space, like through a telescope. The path of light, like if something goes in front of it. Uh, Radial velocity, when something experiences a gravitational pull of an orbiting planet, and like just traveling around. Okay, so this question stumped me for a really long time because it was just like, what is life? And I think we all know the answer is 42. But anyway, these are my reasons of like after researching this for like way longer than I really needed to. These are my reasons for defining life. Having some sort of a body, like being a being of some sort. Evolution capabilities, like being able to evolve. And then reproduction, like being able to like keep the bloodline going. How life formed on Earth according to current biochemical hypotheses. Very long. History of the World, I guess, did a very good summary of it, I will say. But we started off as very tiny little microscopic things, and then DNA was kind of figured out, and then evolution, we were fish. Describe current efforts to detect presence of extraterrestrial technological civilizations. Radio signals, and then just like going out and looking. Just looking. Summarize the primary challenges to human I can't speak, and interstellar space travel. Well, the main problems that I find about humans like traveling through space is the cost, because it is very expensive. Do we have the money? Probably not. Should we be doing it? No. It could also be like the effects that it has on like the world, because like greenhouse gases, we're definitely contributing. Like, oh, Elon Musk and I think is whoever did Blue Origin. I don't know. I really don't care. Some billionaire who has like a space company that just wants to just go to space. I'm pretty sure they're contributing a whole ton to the to the horrors of the world and how the world is going. I mean, also, like, it takes, like, a whole lot of people. So it's just, like, it's not even just, like, the machinery cost, but it's also, like, paying all of these people to go to space and, like, how to get into space just safely. Oof. I'm done.